You already know that every crystal lattice is made of an infinite number of unit cells, and every lattice site is occupied by a constituent particle that may be an atom, an ion, or a molecule. Now let's examine what portion of each particle belongs to a particular unit cell. Consider three types of cubic unit cells. For the sake of simplicity, assume that the constituent particle is an atom. Let's start with a simple or primitive cubic lattice. A simple cubic lattice consists of 8 atoms at the 8 corners of a cube. In the open structure shown here, the distances between the atoms are greatly exaggerated. In reality, the atoms are packed much more closely together, as shown in the space-filling model here. The space-filling model shows that the atoms touch along the edges of the cell. By considering the portion of atoms inside the cell boundary, we can generate a unit cell of a simple cubic lattice. From this, it is evident that each atom at the corners contributes 1/8 of its original volume to each unit cell. There are 8 atoms at the 8 corners. Thus, the number of atoms in each unit cell is equal to 8 corner atoms into 1/8 of an atom per unit cell, which is equal to 1. A body-centered unit cell contains 8 corner atoms, just like in a simple cubic unit cell. However, there is one more atom at its body center. As a result, the atoms at the corners no longer touch along the edges of the cell in the space-filling model. The unit cell of a body-centered cubic cell is shown here. It is clear that the 8 atoms at the corners contribute 1/8 of their actual volume each. In addition, one atom lies completely inside the cell. Therefore, the number of atoms at the corners per unit cell is equal to 8 corner atoms into 1/8 of an atom per unit cell, which is equal to 1. There is one atom at the center of the cube. Thus, the total number of atoms in a body-centered cubic unit cell is 2. The face-centered cubic lattice consists of 8 corner atoms, just like in the simple and body-centered cubic lattice. However, it also contains 6 more atoms at the 6 faces of the cube cell. The atoms touch along the diagonals, and each touches 4 corner atoms. A unit cell of a face-centered cubic cell is shown here. It is clear that the atoms at the corners contribute 1/8 of their original volume each. In addition, there are 6 atoms at the 6 faces, which contribute half of their original volume each. The number of atoms at the corners per unit cell is equal to 8 corner atoms into 1/8 of an atom per unit cell, which is equal to 1. The number of atoms present at the faces per unit cell is equal to 6 atoms at the faces into half an atom per unit cell, which is equal to 3. Thus, the total number of atoms per face-centered cubic unit cell is 4.